At the end of this video, you should be able to distinguish between accuracy and precision. Chapter 2, Section 3, Using Scientific Measurements. If you have ever measured something several times, you know that the results can vary. In science, for a reported measurement to be useful, there must be some indication of its reliability or uncertainty. Accuracy and precision. The terms accuracy and precision mean the same thing to most people. However, in science, their meanings are quite distinct. Accuracy refers to the closeness of measurements to the correct or accepted value for the quantity measured. Precision refers to the closeness of a set of measurements of the same quantity made in the same way. Thus, measured values that are accurate are close to the accepted value. Measured values that are precise are close to one another, but not necessarily close to the accepted value. Figure 2-8 on page 44 of your text, or on the screen now, should help you visualize the difference between precision and accuracy. A set of darts thrown separately at a dartboard may land in various positions relative to the bullseye and to one another. The closer the darts land to the bullseye, the more accurately they were thrown. The closer they land to one another, the more precisely they were thrown. Thus, the set of results shown in A is both accurate and precise because the darts are close to the bullseye and close to each other. In B, the set of results is inaccurate but precise because the darts are far from the bullseye but close to each other. In figure C, the set of results is both inaccurate and imprecise because the darts are far from the bullseye and far from each other. Notice also that the darts are not evenly distributed around the bullseye, so the set, even considered on average, is inaccurate. In D, the set on average is accurate compared with the third case, but is imprecise. That is because the darts are distributed evenly around the bullseye, but are far from each other.
Accuracy is the closeness of measurements to the correct or accepted value of the quantity measured. Precision is the closeness of a set of measurements of the same quantity made in the same way. Consider a game of darts. The target or accepted value is the bullseye in the center. The person who threw these darts is both precise and accurate. All the darts are grouped very close to the bullseye. This graph shows the results of an experiment that was repeated 4 times. Each time the mass and volume of the product were measured. We see that these results are both precise and accurate. They are clustered and very close to the expected value. This set of throws shows that the dart thrower is precise but not accurate. The darts are grouped very close together, but they have missed the bullseye. Here are the results of another researcher's experiments. These results are precise. The data points are clustered close together, but not accurate. Each of these darts landed reasonably close to the bullseye, but the throws are not clustered together and are not precise. In this experiment, the results would average to a value close to the expected value, so they could be considered accurate. They are not, however, precise. Here we have a set of throws that are neither clustered together nor very close to the target. This set of throws is not precise and not accurate. These experimental results, likewise, are not precise and not accurate. When looking at experimental data, precision lets us know the experiment was done carefully in a controlled environment. Accuracy suggests that the experiment has accounted for all factors that might affect the system being studied.
Percent error. The accuracy of an individual value or of an average experimental value can be compared quantitatively with the correct or accepted value by calculating the percent error. Percent error is calculated by subtracting the experimental value from the accepted value, dividing the difference by the accepted value, and then multiplying by 100. Percent error has a positive value if the accepted value is greater than the experimental value. It has a negative value if the accepted value is less than the experimental value. The following sample problem illustrates the concept of percent error. Error in measurement. Some error or uncertainty always exists in any measurement. The skill of the measurer places limits on the reliability of the results. The conditions of measurement also affect the outcome. The measuring instruments themselves place limitations on precision. Some balances can be read more precisely than others. The same is true for rulers, graduated cylinders, and other measuring devices. When you use a properly calibrated measuring device, you can be almost certain of a particular number of digits in the reading. For example, you can tell that the nail in figure 2-9 on page 46 of your text, or on the screen now, is definitely between 6.3 and 6.4 centimeters long. Look more closely, you can see that the value is halfway between 6.3 and 6.4 centimeters. However, it is hard to tell whether the value should be read as 6.35 centimeters or 6.36 centimeters. The hundredths place is thus somewhat uncertain. Simply leaving it out would be misleading because you do have some indication of the value's likely range. Therefore, you would estimate the value to the final questionable digit, perhaps reporting the length of the nail as 6.36 centimeters. You might include a plus or minus value to express the range. For example, 6.36 centimeters plus or minus 0.01 centimeters. At this point, you should be able to distinguish between accuracy and precision.